Hi dears, I'm now going to take up a problem which is involving the use of the principle of Wheatstone's bridge, where if the four branches of the diamond structure satisfy the relation P by Q equal to R by S, then the current through the galvanometer or the middle section joining the pair of terminals, one pair of terminals other than the other pair which is connecting to the battery, no current flows through that section, or in other words, the resistance across that is redundant as if there is an air gap and it is offering infinite resistance, and so that is not included, that is redundant in the circuit. Sometimes the circuit may be somewhat looking complex on the surface of it, on the first look of it, because it may not be showing itself like a diamond structure for you to identify very easily the P, Q, R, and S. So you have to be patiently observing the whole circuit, study the circuit, mark the geometric points as needed, as I'm going to explain now, and then recast it into the diamond structure or the Wheatstone's bridge like pattern of the circuit diagram. And then see if P by Q is satisfying the relation P by Q equal to R by S. If it is done, then the central one, which is connecting the two pair of opposite terminals other than the other pair connecting the battery, will be redundant. And so you have to find the equivalent resistance of the entire network in a simpler way than using Kirchhoff's law and breaking your head over it. This is what I'm going to do. Now, coming to the next part of it, you have now I'm now discussing the problem on this. This is the problem. I'll just move this here. So you see the circuit. Calculate the equivalent resistance between the points A and B of the network. Only they 2 points they have marked. Namely, the two extreme points are A is one end and B is the right end. In between, you have a complex diagram, but it is not shown as a Wheatstone's bridge. It's not shown like a diamond network. But you can easily recast it into a diamond structure as I'm going to explain. Now I'll just off the video so that you can concentrate on the diagram and the audio of it alone. Now look at this. Here you have A and they have marked only A and B. So I am going to mark other points, geometric points, so that you will have no confusion as to what resistance is got between the two terminals. So this particular point I'm calling it as C. This particular point I'm calling it as D. And because A and the left end of 2 ohms are connected by only a connecting wire, if this is A, I will call this as A dashed. If this is D, I'll call this as D dashed. And if this is C, I'll call this as C dashed. That's what I have done here. I have done A dashed. One thing you should remember is that one second. So the naming, how do you name it? At the A and A dash are connected by connecting wires. See here, I have named the top one of the left hand of A2 as A dash and the other one as D dash here. So 2 ohms is connected in between A dash and D dash. And A dash, A that they have given and A dash that you have newly marked are connected by connecting wire. The D is, supposing I'm calling this as D, the one that is between to the left of the right of the 10 ohms, if you call it as D, and in between 1 and 10, the junction there, you call it as C. Now C and the one below it, the left end of the 2 ohms, the top part, the bottommost point is C dashed. And B is connected to B dashed. You call this as B dashed. And A dash, and then this is D dash. This is D, which is vertically above D and connected by D and D dash are connected by connecting wire. So you have D dashed are one the equipotential points. A and A dashed are equipotential points. C and C dashed are equipotential points. And B dashed are equally potential points. If they are equipotential points, then you can write A and adjacent to it A dash without any intervention of any resistance. Similarly, D and D dash. Similarly, C and C dash. And similarly, B and B dash. That's what I'm going to do here. Our the junctions A and A dash are connected by connecting wires of nearly zero resistance. So A and A dash are points of the same potential. Similarly, D and D dash are points of the same potential. C and C dash are points of the same potential. B and B dash are points of the same potential. You can verify B and B dash, C and C dash, A and A dash, and D and D dash are points of the same potential. Now, the junctions A and A dash can be marked as the same one and the same terminal. Similarly, B and B dash can be marked as the same terminal. C and C dash can be marked as the same terminal. D and D dash can be marked as the same terminal. This is what you should know. So I remember all this, and then I have restructured the two diagrams once again in the next page when I'm going to explain this. Right here, you have I have drawn the two circuit diagrams, whatever they have given and whatever we have redrawn here with the terminals here. Now you should remember that they want only the resistance between A and B. So the battery connected two opposite pair of terminals will be A and B. So A and A, B, or A dash and B dash, or anything of your choice. Both adjacent to A, I'll write A dash. So this is A dash and this is D dash. This is C, this is D, this is C dash, this is B dash, and this is B. So A and B should be imperatively the two terminals which are connected to the battery if you want the resistance across between A and B, the two between the two junctions A and B. Now I'll draw this. Look at this. Look at here. One second. Look at the here. Now I will have to take, if I am taking A here, I have to take B here because they want only the resistance across A and B. Now, so you call this as A, and adjacent to this, you call it as A dashed. You call this as B, adjacent to that, you call it as B dashed. And then between A and C, you can have D, C and D will be the opposite terminals. So the resistance caught between C and D is only the 10 ohm resistance. That should come as instead of the galvanometer. So you can have your C here and you can have your D here. Between A and C, you have 1 ohm. Here, A and C, 1 ohm. And then C and B or C and B dash, C and B you have, one second. C and D you have 10 ohms. So this will be my 10 ohms. And then between D and B you have, this is D and B. This is D or D dash. D and B you have 4 ohms here. D and B, C and B, we have already seen this. D and B you have 4 ohms. D and B. D is here, B is here. And here you can write it as 4 ohms, right? And between C and B dashed, see this is B or B dashed. Between C and B dash you have 2 ohms. And between A and D you have A and C is 1 ohm. A and D you have, this is 2 ohms again. So this is 2 ohms. So you have restructured into diamond structure. So here you have your P, which is 1 ohm. Here you have your Q, which is 2 ohms. Here you have your R, which is 2 ohms again. And here you have S, which is 4 ohms. Now P by Q will be equal to 1 divided by 2, which is half. 1 divided by 2, that is equation 1. And then in second equation, R by S, I'm going to see. R by S will be, R is 2 ohms, S is 4 ohms, and 2 by 4 is also equal to 1 by 2. So from 1 and 2, right hand sides are equal. Therefore, it follows that P by Q equal to R by S. And that also implies the 4-arm bridge, that is Wheatstone's bridge, is balanced. That means which is redundant? What comes at the center is redundant, and therefore the 10 ohm that is going to be serving the 10 ohms resistor and instead of, in place of galvanometer, has a zero resistance, as has IGI R equal to 0. Therefore, R or equal to 10 ohms is redundant from the circuit. You don't have to connect that. Don't have to consider that. But that's not 0. But it is redundant, as if there is an air gap between C and D. That's the thing. Because the distance between air gap between C and D. Therefore, the equation now will become, this is, here you have the four arms here, and here you have A and A dashed, and on top you have C and C dashed, here C and C dashed, and this is your B and B dashed, and this is your D and D dashed. This is how it is. Between A and C, you have 1, 2, 2, 4. Here, like this. So it is 1, 2, 2, 4. As if there is an air gap here, and this is redundant, and therefore it is just like an open key here. That's why no current flows through this particular section. Potential at C is equal to potential at D, because it is not allowed to, current is not allowed to flow. There is no potential drop. Now that means P and Q, this is R and S. So the entire network is equivalent to network between A and B is equivalent to P series Q, the whole thing being parallel to R series S. That is the entire network between A and B. So here it will be 1 series 2 parallel to 2 series 4. That will be equal to 1 series 2 will be 3, parallel to 2 series 4 will be 6. Series means you have to add both, 2 plus 4. Series of 1 and 2 will be 1 plus 2, 3 parallel 6. Whenever you have R1 parallel to R2, the easy ready reckoner value is given by, or circuit will be given by product of the two by sum of the two. This is one easier method that you have to employ for finding out the answers immediately. So here 3 and 6 are in parallel. Therefore 3 times 6 by 3 plus 6 will be the answer. That will be 18 divided by 9. That will be simply 2 ohms. So the answer or resistance between A and B is equal to 2 ohms. That's the answer you have to say. Even if you use different closed circuits and apply Kirchhoff's law and try to solve the problems, you will get the same answer as this. But this is an easier method. So always in complicated circuits, you first try whether it is giving out a Wheatstone's like bridge. Um, so you first try if it is giving a Wheatstone's like bridge circuit, and then that failing alone, you can go and find out, search out for closed loops, how many ever independent loops are there, as I explained in the earlier session, and then use Kirchhoff's law and find out the various currents and whatever it is, and then have a long procedure. And finally, if you don't go wrong, you will land up into the same answer. The same answer can be got by recasting into a diamond structure somewhat similar to Wheatstone's bridge, and seeing if there is a balanced Wheatstone's bridge, then your problem gets solved very easily, as simply as this. I think you have understood this. So you can try more problems on this and get back if you have any doubts in any of the standard textbooks given in the, or you can write out the problem and then take my help. Thank you very much.